inverse trigonometric functions. Before going to the properties of inverse trigonometric functions, we have to know what are the domain and ranges of inverse trigonometric functions. Then only we can understand easily this particular concept. And as well as we have to recall what are the properties, what are the formulas we have learned in +1. Nothing but sin 2x, the trigonometric formulas, sin 2x, sin 3x, tan 2x, tan 3x, cos 2x, cos 3x, cos x by 2. So what are the relations? These all relations you must recall. Then you have to start listening this lecture as well as viewing this video. Right. Now, before entering to the properties, I want to explain what about the modulus of x less than or equal to 1 and modulus of x greater than or equal to 1. So what it specifies? Modulus of x less than or equal to 1 represents plus or minus x less than or equal to 1. So x less than or equal to 1 minus x less than or equal to 1. So from this we can write that x greater than or equal to minus 1. So if I take a number line minus 1, 0, 1, x greater than or equal to minus 1 and x less than or equal to 1. So where x lies? X lies in between minus 1 and 1. Therefore minus 1 less than or equal to x less than or equal to 1. This can be simply we can define or we can indicate like modulus of x less than or equal to 1. In the same way, what about modulus of x greater than or equal to 1? So modulus of greater than or equal to 1, x plus or minus x greater than or equal to 1, x greater than or equal to 1 minus x greater than or equal to 1. Then what we get? X less than or equal to minus 1. Take number line. Minus 1, 0, 1. X less than or equal to minus 1. X greater than or equal to 1. So the value of x is greater than or equal to 1. It is less than or equal to minus 1, which is nothing but x is equal to minus infinity to minus 1 union 1 to infinity. So this one we can simply define or we can write like modulus x is greater than or equal to 1. So if I remove this equal to, which is nothing but 1 and minus 1 are open. That the same way 1 and minus 1 are open. If I remove this minus, this equal to. Now we enter into the properties. Property number 1. Sin inverse of sin x. Sin inverse of sin x. Property number 1. Sin inverse of sin x, nothing but sin of sin inverse x is equal to 1. For what values of x it is defined? So for x it particularly depends on x because it's an inverse trigonometric function. So it is defined only for modulus of x which is less than or equal to 1. Let sin inverse x take as y. Then x is equal to sin y. So x is equal to sin y can be replaced as sin inverse x. So we can prove sin of sin inverse x is equal to x. In the same way we can write as cos inverse x is equal to x for its particular domain modulus of x less than or equal to 1. One more, tan inverse x is equal to x for all real numbers. So x belongs to real number. Cot inverse x is equal to x for all real numbers. Secant inverse x is equal to x for all x belongs to real numbers minus 1 comma 1, which can be rewritten as modulus of x greater than or equal to 1. Then similarly cosecant inverse x is equal to x for all x greater than or equal to 1. Next, property number 2. property number 2, sine inverse of sin x is equal to x. See, sine inverse defined if this particular value is lies in between minus 1 comma 1. So for what values sin x lies between minus 1 comma 1? For the values x which are belongs to minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. So here what are the values of x? X belongs to minus pi by 2 to pi by 2. Okay. In this previous class, previous case, in this first property, the x values are lies in between minus 1 and 1, then only inverse sine function exists. Here inverse sine function exists when sin x lies between minus 1 and 1. If sin x lies between minus 1 and 1, x lies in between minus pi by 2 to pi by 2. Now we'll see the proof. Take sin x as y, sin x as y, then x is equal to sin inverse of y. So sin inverse of y can be replaced as sin x. So sin inverse of sin x is equal to x. Sin inverse of sin x is equal to x. Similarly, we can prove for cos inverse of cos x is equal to x. Where it exists? X belongs to 0 to pi. Similarly, tan inverse of tan x, cot inverse of cot x, secant inverse of secant x, cosecant inverse of cosecant x. All the formulas you have to write in your classwork. Next, property number 3. Property number 3. Sin inverse of minus x equal to minus sin inverse x. Cos inverse of minus x equal to pi minus cos inverse x. See, these all things are defined only in their particular domain. Their particular domain, modulus of x less than or equal to 1. For this, modulus of x less than or equal to 1. And the next, tan inverse of minus x equal to minus tan inverse x. Its domain x belongs to, or tan inverse of minus x got over cot inverse of minus x is equal to pi minus cot inverse x. X belongs to, or cosecant inverse minus x equal to minus cosecant inverse x, where x greater than or equal to 1. Secant inverse minus x equal to pi minus secant inverse x. So why we are getting minus for this and for this? The difference is between these two. You see, these all three are defined their ranges. These all three having their ranges in between minus pi by 2 and pi by 2. So they got directly in a fourth quadrant, we got it their negative values. But coming to this, these are not belongs to the fourth quadrant. These are the functions where they have got their ranges in between first and second quadrant. So if we get the particular value in fourth, the range, we have to convert that fourth one into second quadrant. See, tan inverse of minus x. I am doing the second. Tan inverse of minus x equal to minus tan inverse x. So to prove this, let tan inverse x be some variable y. X is equal to tan y. I don't want x, I want minus x. So minus x is equal to minus tan y. Minus x is equal to minus tan y. Now what I can do, I have to apply tan inverse. So send this tan inverse. See, minus x is equal to minus tan y can be written as tan of minus y. So tan inverse of minus x, tan inverse of minus x is equal to minus y. We can replace this y by tan inverse x. So we get tan inverse of minus x as minus tan inverse x. The same thing if we come to the next one, cot inverse of minus x, cot inverse of minus x equal to pi minus cot inverse of x. Cot inverse of minus x is equal to pi minus cot inverse of x. So let me try this one. Let cot inverse of x be some y. Cot inverse of x, consider it as y. Then what I get, x is equal to cot y. Then minus x is equal to minus cot y. See, cot is negative in second quadrant and fourth quadrant. Tan is negative in second quadrant and fourth quadrant. But tan inverse does not lie in second quadrant. That's why I took minus tan y as tan of minus y. Coming to this cot, so we can take in second quadrant as well as fourth quadrant. But cot inverse doesn't lie in fourth quadrant. So we have to take in a second quadrant. If I want to take anything in second quadrant, what I have to do? I have to replace the theta by pi minus theta. So minus x can be written as cot of pi minus y. Then cot inverse of minus x is equal to pi minus y. Replace the value of y. Cot inverse of minus x is equal to pi minus cot inverse x. Pi minus cot inverse x. Next, property number 4. Property number 4. Cosecant inverse x is equal to sin inverse 1 by x. Secant inverse x is equal to cos inverse 1 by x. Cot inverse x is equal to tan inverse 1 by x and pi plus tan inverse 1 by x. So why we got for cot alone 2 values, and for what values, how we split this one? See, for what values of x cosecant inverse is existed? For values mod x greater than or equal to 1. And for what values of x secant inverse existed, which is nothing but x modulus of x greater than or equal to 1. For what values of x cot inverse exists. Cot inverse exists for all real numbers. See, all real numbers except 0. We cannot take 0. If I take 0, we get not defined. So what I have to take? We get two portions. What are less than 0 and greater than 0. If I get greater than 0, it's nothing but tan inverse 1 by x. If it is less than 0, pi plus tan inverse 1 by x. What is the reason behind this? Why we are getting cot inverse x 2 and remaining 2 are only single value. See, cosecant inverse and sin inverse are defined in minus pi by 2 and pi by 2. Whereas cosecant inverse we don't have a we don't have 0 in that one particular value will be excluded in this particular interval. And secant inverse is defined in between 0 and pi, secant and cosecant inverse, whereas pi by 2 is excluded for secant inverse. But if I go into the cot inverse, it's completely different. These two are almost same, their ranges except only one value. But coming to this, these are completely different. Cot inverse is defined in between 0 to pi, and tan inverse is defined in between minus pi by 2 to pi by 2. So because of this change, we got two particular values. We take quadrant table. See, Chord inverse defined in between first quadrant and second quadrant pi by 2. First quadrant and second quadrant. We cannot consider 0 and pi by 2. Tan inverse defined in between first quadrant and fourth quadrant, whereas pi by 2 and minus pi by 2 are excluded. See, this particular thing is same for both, for chord inverse as well as tan inverse. So that's what we got directly. Chord inverse x is equal to tan inverse 1 by x when x greater than 0 in this particular part, which is nothing but 0 to pi by 2. 0 to pi by 2 means tan inverse x. Tan inverse x, where tan inverse x lies, nothing but we take it as y between 0 to pi by 2. If we consider this chord inverse which is lying in between pi by 2, chord inverse function lying in between pi by 2 to pi by 2 to pi, we don't have any values which satisfies tan inverse. So we have to convert this particular branch into tan, where tan existed. So we have to convert this second quadrant into second quadrant into fourth quadrant. In what way we can convert? So we have a 2 quadrants gap between this, so we can add pi to the resultant, what we got in the previous case. So in this particular case, what we get, chord inverse of x is equal to pi plus tan inverse of 1 by x, where x less than 0. We go for proof. Chord inverse x, let chord inverse x equal to y, x is equal to chord y. I am converting this chord in terms of tan, so take reciprocal. 1 by x is equal to 1 by chord y. So 1 by x is equal to 1 by chord y can be written as tan y, but tan y is defined in between minus pi by 2 tan y, minus pi by 2 to pi by 2. We are converting chord into tan, so we have to split that interval 0 to pi into 2 parts. So where I took this one as 0 to chord inverse x less than pi by 2 part. Then we get tan y as 1 by x. Now tan inverse y, tan inverse 1 by x is equal to y. So tan inverse 1 by x is equal to y. What is y? Chord inverse x, where in between this particular region. The next region, what is the next region? So 0 to pi by 2 got over. See, minus pi by 2 to pi by 2, what we have? Minus pi by 2, we get 0, next we get pi by 2. So we got in between this, and we need to get this particular thing, minus pi by 2 to 0, and what we have in a chord, see 0 to pi, we get from 0 to pi by 2, and then from pi by 2 to pi. So this particular part, first part got over. What the first part? 0 to pi by 2, 0 to pi by 2. I have to convert this pi by 2 to pi in terms of minus pi by 2 to 0. How I can convert? So if I have pi by 2, I consider chord inverse x as y. So y is lying in between pi by 2 and pi. I don't want pi by 2, I want this one as minus pi by 2 to 0. Minus pi by 2 to 0. So what I can do? Subtract pi. Subtract these all things from pi. So pi by 2 minus pi. Pi by 2 minus pi less than y minus pi less than pi minus pi. So I added minus pi for all the elements. Then what I get? Minus pi by 2 less than y minus pi less than pi minus pi 0. So in between this interval, y acts as y minus pi. means cot inverse x acts as y minus pi. So x is equal to, what I can write, cot y minus pi. I can write it as cot y minus pi. 1 by x is equal to 1 by cot y minus pi. So 1 by x is equal to tan y minus pi. Tan inverse of 1 by x is equal to y minus pi. Transfer minus pi to left side. Pi plus tan inverse of 1 by x is equal to y. Y is nothing but cot inverse x. See what we did. We have converted this second quadrant elements to fourth quadrant element. That's what I have done here. Just go through with this proof, but we have to remember the formulas. Next, property number 5. Property number 5. Sin inverse x plus cos inverse x equal to pi by 2. Tan inverse x plus cot inverse x equal to pi by 2. Secant inverse x plus cosecant inverse x equal to pi by 2 in their respective domains. See, in trigonometric and inverse trigonometric functions, especially in inverse trigonometric functions, we have to concentrate on conditions. This exists not for all real numbers, only for modulus of x less than or equal to 1. Even this exists not for all real numbers. Yes, for tan, all real numbers, x belongs to R. And for secant, it's not for all real numbers. It exists in between minus infinity to minus 1 union 1 to infinity. So we go to the proof. Sin inverse x plus cos inverse x equal to pi by 2. If I take sin inverse x as y, then what I can write, sin inverse x as y, x can be written as sin y. X can be written as sin y. Now the same sin y, how I can convert in terms of cos? Sin can be converted in terms of cos, like sin 90 minus theta is cos theta. So I can write it as x is equal to sin theta. I have theta as y, 90 minus theta, which is cos theta. So I can rewrite this sin y as cos 90 minus theta. Sin y can be written as cos 90 minus theta, which we took from complementary angles. Now cos inverse x can be written as pi by 2 minus y. So cos inverse x is equal to pi by 2 minus, what is y? Sin inverse x. Transfer sin inverse x left side. Sin inverse x plus cos inverse x, which is equal to pi by 2. In the same way, we can prove the rest. Next, triangle rules. With the help of triangle, we relate sin to cos, cos to sin, tan to cos, cos to tan. See, so how we are going to relate those? Sin inverse of x by root of 1 plus x square equal to tan inverse x. Sin inverse of x by root of 1 plus x square is equal to tan inverse x. So we'll see for what values it is defined. Later we'll see. Sine inverse of something we have. This something should be belongs to its domain. So this entire part should be belongs to -1 to 1. It should lie in between -1 to 1. Whatever the value I substitute in place of x, what I get improper fraction or proper fraction. What I get? X and 1 plus x square under root. You can check if I have x value 2, 1 plus x square, 2 square, 4 under root 5, 2.14. 3, root 10, 3 point something. So always numerator is smaller than the denominator, will get always proper fraction. So proper fraction always lies in between -1 and 1. So whatever the value of x you take, will get this particular value in between -1 and 1. So x belongs to real number. Now with the help of this we have to define this. So for x belongs to R, what is the domain of tan inverse x? All real numbers. So from these two, what you can write, the x belongs to R. See, I am going to prove this. Tan inverse x. Take tan inverse x as y. Then tan y will be equal to x. Take right angle triangle. Now what I can write? If I take this angle as y equal to x, so tan y equal to x, opposite by 1. So hypotenuse is root of 1 plus x square. So from this what I can write? I want to relate this tan in terms of sine. So sine y is equal to x by root of 1 plus x square. So y is equal to sine inverse of x by root of 1 plus x square. What is y? Y is tan inverse x. So tan inverse of x is equal to sine inverse of x by root of 1 plus x square. So if I want to convert this in terms of cos, what I can do? Instead of taking sine y, I take cos y. Cos y is equal to 1 by root of 1 plus x square. Y is equal to cos inverse of 1 by root of 1 plus x square. So tan inverse of x is equal to cos inverse of 1 by 1 plus x square under root. Now you can convert in terms of secant, you can convert in terms of cot, you can convert in terms of cosecant. So with the help of this triangle method, we can convert anything in terms of the other inverse trigonometric ratio. But after getting this inverse trigonometric ratio, we have to define where x lies. You take tan inverse and cos inverse. Tan inverse lies in between first and fourth quadrant. Cos inverse lies in between first and second quadrant. So these two are defined in intersection portion only. So where defined in between 0 and pi by 2. In between 0 and pi by 2. 0 and pi by 2. Pi by 2 is included in this. Pi by 2 is not included. 0 is included. See, in between these two it is defined. So in between these three defined values 0 to infinity. Okay, these are ranges. Cos inverse x and tan inverse x both lies in between this particular thing. So for what values of x we will get these two, the values which are from 0 to infinity. 0 to infinity, now we can say x belongs to 0 to infinity, nothing but x is greater than 0. In the same way, suppose we want to find the next property, we want to go for the next property, which is nothing but they have given sin inverse x is equal to tan inverse of x by root of 1 minus x square. Root of 1 minus x square. So if they have given this, so I take the sin inverse x as y. I take the sin inverse x as y. Sin inverse x as y. See, if I take sin inverse x as y, so what happens? I consider one right angle triangle. So I take this as y, means I get x is equal to sin y. So y sin y opposite by hypotenuse. I want adjacent. How I get adjacent? Root of hypotenuse square minus opposite square 1 minus x square. So I want to relate this sin in terms of tan. So I write the value in terms of tan. So tan y is equal to x by opposite by root of 1 minus x square. So y is equal to tan inverse of x by root of 1 minus x square. What is y? Sin inverse x, which is equal to tan inverse x by 1 minus x square under root. Same, we can express this sin inverse x in terms of cos also with the help of triangle. So it's a very important model. See, we can write cos y is equal to root of 1 minus x square by 1. Therefore y is equal to cos inverse of root of 1 minus x square by 1. Y is nothing but sin inverse x. So sin inverse x is equal to cos inverse 1 minus x square under root. So one more property what we have, cos inverse x is equal to tan inverse of root of 1 minus x square by x. Prove that tan inverse of root of 1 minus x square by x, which is equal to cos inverse x. Take cos inverse x as y, then what we get, cos y is equal to x. So similarly, you take right angle triangle, select the angle y, x, hypotenuse is 1. So what we get here, root over 1 minus x square. So root over 1 minus x square. Therefore what I can write, tan y is equal to root over 1 minus x square by x. Y is equal to tan inverse root over 1 minus x square by x. Y can be replaced as cos inverse x, which is equal to tan inverse of root of 1 minus x square by x. If I want to express in terms of sin, what I get, sin y is equal to root of 1 minus x square by 1. So y is equal to sin inverse of root of 1 minus x square. So cos inverse x is equal to sin inverse of root of 1 minus x square. So from this and this we can write one more formula, which is nothing but sin inverse x is equal to cos inverse of root of 1 minus x square, or cos inverse x is equal to sin inverse of root of 1 minus x square. From these two we can derive one more thing, cos of sin inverse x is equal to, so what I can write, cos of sin inverse x. Sin inverse x can be written as cos inverse root 1 minus x square. Cos inverse x is x, so we can write it as root of 1 minus x square. So cos of sin inverse x is equal to root 1 minus x square, or sin of cos inverse x. So this cos inverse x can be written as sin inverse root 1 minus x square, which is nothing but equal to root of 1 minus x square. So after this, we go to the next property. The property is nothing but, the properties are depending on compound angles, multiple angles and submultiple angles. Compound angles, multiple angles and submultiple angles. See, these are the formulas. Next formula is very important, most frequently used in the problems. We can easily remember those with the help of our trigonometric formulas. See, tan inverse of x plus tan inverse of y is equal to tan inverse of, so we can take this entire part as a, this entire part as b. We can apply tan of a plus b can be written as tan a plus tan b by 1 minus tan a tan b. So if I apply the same thing, tan a plus tan b, so tan a becomes x. Why tan a becomes x? Okay, tan inverse x we consider as a, then x is equal to tan a. Tan inverse y we consider as b, then y is equal to tan b. So if I take a plus b and apply tan on both sides, then what I get, tan a plus tan b by 1 minus tan a tan b. Tan a plus tan b by 1 minus tan a tan b. So if I send right side, then what do you get, a plus b is equal to tan inverse of tan a plus tan b by 1 minus tan a tan b. Now replace, a can be written as tan inverse x, so tan inverse x plus tan inverse y is equal to tan inverse of tan a. What is tan a? X. So x plus y by 1 minus xy. But there we have a problem. What is that problem? If xy is greater than 1, what is our formula? If xy is less than 1, then what is formula? What is our formula? If xy is greater than 1, we get tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. If xy is less than 1, then what we get? We get pi plus tan inverse of x plus y by 1 minus xy. Pi plus tan inverse of x plus y by 1 minus xy. If I want to find tan inverse of x minus tan inverse of y, so what I get, tan inverse of, it's looking like a minus b, tan a minus b formula, which is nothing but tan a minus tan b, x minus y by 1 plus tan a tan b, 1 plus xy. For this we get only one formula for all the values. Next, multiple angle of this tan. Multiple of this tan, if I want to convert into sine, if I want to convert into cos, if I want to convert into tan. See, sine inverse of, so what is the sine 2 theta in terms of tan? Sine 2 theta in terms of tan. See, I can write sine 2 theta equal to 2 tan theta by 1 plus tan square theta. Cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square theta. Tan 2 theta is equal to 2 tan theta by 1 minus tan square theta. Same, replace tan theta as x. Replace tan theta as x and substitute. If I consider tan theta as x, then we can write theta is equal to tan inverse x. So sin inverse we get as theta. Yes or no? Sin inverse of some number, you take -1. What I am getting? -pi/2, which is nothing but angle theta only, no? So we consider this as a variable x. I consider here as theta. That is only the difference. So if I take tan theta as x, then theta will be equal to tan inverse x. So if I replace these all things, what I get? Sin 2 tan theta. So 2x by 1 plus x square, which is equal to 2 tan inverse x. In the same way, we can get for cos and sin. Same. So what I get? Cos inverse of 1 minus x square by 1 plus x square is equal to 2 tan inverse x. See, in another way, tan in terms of tan inverse of 2x by 1 minus x square is equal to 2 tan inverse x. See, if I want to relate tan inverse in terms of half angles, then what I get from this? I can write tan inverse x as 1 by 2 sin inverse of 2x by 1 plus x square, which is equal to 1 by 2 cos inverse of 1 minus x square by 1 plus x square, which is also equal to 1 by 2 tan inverse 2x by 1 minus x square. See, this we use frequently in the problems, and these all things are defined for its particular domains only. See, sin inverse x and tan inverse x both are defined, where those two are defined in between -1 and +1. Cos and tan. So if you take these two, those two are defined in between first quadrant, which is nothing but 0 to pi. So 0 to pi by 2. So in that way we get the values of x, nothing but domains. The next one in terms of cos and sin. So in terms of cos and sin, sin inverse x plus sin inverse y. Sin inverse x plus sin inverse y. If I suppose sin inverse x, if I take it as A, sin inverse y, if I take it as B, then x acts as sin A, y acts as sin B. Now, if I apply this A plus B, if I apply sin both sides, what I get? Sin A cos B plus cos A sin B. Sin A cos B plus cos A sin B. See, I have sin A and I have sin B. I don't have cos A cos B. With the help of this, I have to find out cos A as well as cos B. If sin A is equal to x, what is cos A? Root of 1 minus sin square A, which is nothing but 1 minus x square. If sin B equal to y, what about cos B? Cos B is equal to root of 1 minus y square. So simply replace this. What I get? Sin A plus B is equal to sin A. Sin A is x. Cos B is 1 minus y square plus sin A. Cos A is 1 minus x square under root into sin B, which is equal to y. So if I want sin inverse x plus sin inverse y, So I have to transfer this sign to right side. What I get? Sin inverse of x into 1 minus y square under root plus root of 1 minus x square into y. This is existed for only x square plus y square greater than or equal to 1. If x square plus y square is less than 1, so we get a formula like pi minus. See, in this particular case means x value, y value both are more than 90. So more than 90, then our value converted into second quadrant or third quadrant. Those quadrants we have to convert into first or fourth. So for that we have to subtract the given values from pi. So what I get? Pi minus the as usual thing, sin inverse of x root 1 minus y square plus y root 1 minus x square. If I want to get sin inverse x minus sin inverse y, what we can replace? We can replace plus as minus, then we'll get is sin inverse x minus sin inverse y. Similarly, you can say the formula for cos inverse x plus cos inverse y. So cos inverse x plus cos inverse y. Cos a plus cos b depends on cos a plus cos b. So which is nothing but cos inverse of x we take as a. So wherever we get cos inverse cos a, we replace by x. Cos b we replace by y. With the help of cos a cos b, I have to find sin. So if cos a is x, what about sin a? Root of 1 minus x square. If cos b is y, then what about sin b? Root of 1 minus y square. So from that, what I can write? Cos inverse x plus cos inverse y is equal to cos inverse of cos a cos b, which is nothing but xy, plus sin a sin b, root of 1 minus x square into 1 minus y square. If it is minus, cos a plus cos a cos b minus sin a sin b. If I want cos inverse x minus cos inverse y, if I get here minus, then this minus becomes plus. So the same way we can go to 3 multiply, means the sin 3. So 3 sin inverse x can be written as 3 sin inverse x, nothing but sin 3 theta formula. Sin inverse of 3x, 3 sin theta minus 4 sin cube theta. So where x lies for this particular cases, where x lies? This total actually sin inverse x, which is nothing but y, y lies in between minus pi by 2 and pi by 2. But in this particular case, this is 3y. So 3y lies in between minus pi by 2 and pi by 2. Then what about y? So divide by 3. Then what I get? Minus pi by 6. Minus pi by 6 less than or equal to y less than or equal to pi by 6. Okay. So divide everything by 3. So we get minus pi by 6 less than or equal to y less than or equal to pi by 6. Then what about the sign? Its domain. What about x? So substitute in sin inverse of minus pi by 6. Sin inverse of minus pi by 6 is equal to, so what is the value of sin inverse of minus pi by 6? Minus sin pi by 6 minus 1 by 2. So it lies between minus 1 by 2 and 1 by 2. The same way, 3 cos inverse x, cos 3 theta formula, 3 cos theta, cos inverse x, cos 3 theta formula, 4 cos cube theta minus 3 cos theta. So we write it as 4 cos cube theta minus 3 cos theta. Now where x lies? This is the value of x. Similarly, the same thing for cos also, it lies in between minus pi by 2 and pi by 2, but which is nothing but 3y. 3y. So if I consider y, we get minus pi by 6 to plus pi by 6, minus pi by 6 to plus pi by 6. Sorry. For cos lies in between 0 and pi. For cos it lies between 0 and pi. So if I divide by 3, I get 0 less than or equal to y less than or equal to pi by 3. Y less than or equal to pi by 3. Now apply cos inverse. Cos inverse 0 is 1 less than or equal to cos inverse x, cos inverse y, which is nothing but x, less than or equal to cos inverse pi by 3, cos inverse pi by 3, cos inverse pi by 3. What the value of cos pi by 3? So what value of this? We get pi by 3. See, so we have to apply this one. Cos pi by 3. Cos pi by 3 is 1 by 2. Cos pi by 3 is 1 by 2. So what I get? 1 less than or equal to x less than or equal to 1 by 2. So if I go to tan 3, tan inverse x is equal to tan inverse of 3 tan a minus tan cube a by 1 minus 3 tan square a. 3 tan a minus tan cube a by 1 minus 3 tan square a. So for this tan, again y lies in between minus pi by 2 and pi by 2, but it is not y, it is 3y. So we have to divide everything by 3. Then what I get? Minus pi by 6 less than or equal to y less than or equal to pi by 6. So what about cos tan minus pi by 6? Tan minus pi by 6 minus 1 by root 3 less than or equal to x less than or equal to 1 by root 3. So these are the particular formulas what we have in our inverse trigonometric functions. So if you learn these formulas perfectly, we can solve the problems very easily. Okay.